Hey Algebra 2, today we're going to do arithmetic series. So how do we do an arithmetic series? If you remember the difference between a sequence and a series, is a sequence is just a list of them in the pattern, while a series is adding them all up. So yesterday we learned how to make the rule for a sequence, which if you don't remember, is a of n equals a of 1 plus d n minus 1. So that's how you make a sequence. What we're going to do today is that we're going to figure out a quick way to find the sum of a bunch of terms. So yesterday in our homework, we did it up to 20. Today, we're going to use 20 again, but it'll be very hard to write down each one from 1 to 20 and add them up. So today, we're going to do a practice on how to use the equation to add an arithmetic sequence or an arithmetic series. And this is the equation. So this is the important part right here, guys. So S of n, so that capital S stands for sum, which remember sum means add it all up. It could also stand for series. So the series up to the n step. So the n step means how many steps I'm going. Usually, sometimes it's 20, sometimes it's 100, sometimes it's a billion. So the sum of this n step, it's going to be n. So how many steps I took times a1 plus an divided by 2. So what we're happening here is I'm going to multiply it by n, how many steps, times the average of the first step and the last step. So we're taking the average of the first step and the last step, or whatever step I'm going to, in this case, a of n. So if I was going to step 20, this n would be 20, and a of 20 will be some value, which represents the 20th step. Okay? So let's see how our questions are going to look like. So we're going to have a sigma. So we're going to say from n equals 1 to, let's not use such a big number. Let's use 10 today. And it's 4 plus 3n. Okay? So this is an arithmetic sequence, and we know that because the d is a normal number, and we're just adding each time. So we're going to use this equation up here to solve this. So in order to solve this equation, we need this variable, and this variable. So it's on us to identify that. We need n, a of 1, a and n. Okay? So before we can even solve this, we need to figure out these guys over here. So how do we figure out those guys? First one is n. N is how far am I going? So I look at this picture and try to look, how do I know what is my last step that I'm going to? The last step you're going to is the top of the sigma. So your n is always the top over here. So that's 10. Now I need to find a of 1. What does a of 1 means? That's how much it is on the first term, so the first term. So that means I'm plugging into here 1. So 4 plus 3 times 1. 4 plus 3 is 7. So my first term is 7 when I plug in a 1 into this n. 7. Now I need to find a of n. We just said n is 10. So I need to find it. What is the number on the 10th step? In order to do that quickly, I plug it into here, 10. So it becomes, let me put it here, 4 plus 3 times 10. That's 4 plus 30. So that's 34. So my 34 is my, second term. So 34 is my last term that I'm going to. Now we have all the actors in place, we could start this off. So I'm going to use this equation over here. So it is S of 10, because I'm going to the 10th step, equals 10, this n becomes 10, a1, which was 7, plus an, which was 34, divided by 2. So now we're just going to do some simple, this is not technically algebra, this is just straight PEMDAS stuff. So we're going to add the top of the fraction first. 7 plus 34 is 41. 41 divided by 2. And again, if you have a calculator, you could do this all in calculator, is 20.5. And then 10 times 20.5 is 205. So your answer in this one is 205, okay? So that is the basics of using this equation for these type of problems. I put 6 problems for homework, I believe. So we're going to do a lot of practice with this, all right? But it's pretty straightforward. It's just a lot of integral parts to it. But you guys are going to be able to handle this, all right? All right, see you soon on Zoom.